This conference will now be recorded.
Good morning, everyone. Is there anyone who can hear me? Hello? Can you hear me, my voice? Is here? Hello?
Hello, Gabriel.
Can you hear me?
Yeah, I can hear you. Yeah.
Thank you, thank you. Okay, so we can start right now, the presentation.
Okay.
Okay. So mute yourself when you join the session.
What, Gabriel?
Mute yourself. Mute your mic.
Okay.
Okay, thank you. So welcome back, everyone. Welcome back to this webinar. And the topic for today's webinar is on link aggregation principle and configuration. So by this training, you will be able to understand what is link aggregation and how we can configure link aggregation on Huawei devices. Okay. So since we have very limited time, I will try to cover all the important concepts about link aggregation at HCIA level. Okay. We are talking about at HCIA level. So before starting the session, let me give you a chance. If you have any question, on how we can start the training, do you have any question before starting the session that you want to ask? Do you have any question? Hello? Do you have any question before start the session? If you have any question, I can hear you. Okay, good. Let's start. So, what is link aggregation? What does it mean, link aggregation mean? What's link aggregation? Who can tell me? Who can define what's link aggregation mean? Is there anyone who can define the meaning of link aggregation? Is there anyone who can try?
Yes, it's a grouping of physical. It is a grouping physical interface into one logical interface.
Thank you very much. Thank you. Okay, thank you. So, as he said, link aggregation is a technology. It is a technology that allow us to group or combine or bundle bunch of or multiple individual physical links into a single logical link with high bandwidth. Okay. So let me write it down the definition here. Can you use the screen writer or the pen? Can you see it? Okay, thank you.
Yes, I can see it.
Thank you. So let me write down the definition. The definition from what I know. Okay, the link aggregation or ether channel or ether trunk is a technology or a bundling technology. It's a technology that allows us to bundle allow us to group or bundle or combine multiple physical links into a single logical link with high bandwidth. Okay, high bandwidth. Okay, so by implementing logical or by implementing link aggregation or ether trunk technology, we can allow or we can add the following advantages. Okay, the first advantage of link aggregation is, who can tell me the advantage of link aggregation? The first is it increase. Hello.
Yes, also I think it's also redundancy.
Yeah, right. It is also called as redundancy. Yeah. So the first advantage of link aggregation technology is it improves, okay, or increases. The first advantage is increase. Okay, it increase the bandwidth. Okay, the bandwidth. The second advantage is by implementing the link aggregation, we can improve. Okay, improve the network reliability. Okay, the network reliability. And the third advantage of link aggregation is it will allow traffic load balancing. Okay, traffic load balancing. Please take note. Please don't forget this one. The first concept that you have to understand is what is link aggregation mean. Okay, so link aggregation is a technology that allow us to bundle or to group or to combine multiple physical links. Okay, not single, multiple. We are saying multiple physical links. Okay, into a logical link, to provide high network bandwidth or to increase the bandwidth of the overall network, to improve the network reliability, and to implement traffic load balancing. We will see each of this one by one later. Okay, so as a means of optimizing the throughput of data, link aggregation enables to the binding of. This is what we are saying. The link aggregation enables the binding of multiple physical. We are saying multiple physical interface into a single logical pipe. Okay, this is into a single logical pipe. This effectively introduces solutions for providing higher utilization of available links. Yeah, as well as extended resilience in the event that a failure of individual links were to occur. This is the event where if a single link were failed, then the backup link will act as the active links. So engineers are required to have a clear understanding of the conditions that define the behavior of link aggregation and the skills and the knowledge of its application. Okay, you have to understand in which scenario is applicable to ensure effective link aggregation solution can be applied to enterprise network. So in an enterprise network, it's mandatory. It is very important to implement this technology. Okay, so can you see the screen? The pen? Can you see? Hello? Can you see it? Can you see the screen, please? Okay, good. So link aggregation is a technology that allows us to group or to combine or bundle individual multiple physical links into a single logical link. Okay, into a logical. We are combining multiple physical links to provide what? To provide network reliability, to traffic load balancing, and to increase the bandwidth. Okay, so what does it mean? For example, you can have switch 1. Okay, this is switch 1 and switch 2. This is switch 2. Okay. So if you connect these two switches using a single link like this, then if this link is broken down, if this link fails, then what? The communication between these two switches or all the users which are connected to these two switches will not be able to communicate. So this means the entire communication is failed. So the users cannot communicate to each other. So what we have to do is we have to provide we have to add additional links that act as like redundancy. So when this link fails, that this will become active or take over of the responsibility of this link. So this then without delay, with no delay, then or almost with very few seconds of delay, then this link will become active and then the communication will continue. Okay. So
I have a question. So if I have one link, that means if the link is down, that means it's a single point failure.
yeah, single point of failure. Excellent. So the Ethertrunk technology will eliminate the single point of failure, link failure. We are talking about we are not talking about the device reliability. Okay, we are talking about the link reliability. We have to take care of this link reliability, device reliability. Okay. So if there is a single link of, connected to the two switches, then if this link becomes down, then how this users or employees connected to the two switches can communicate? There is no mechanism. These employees which are connected to switch 1 and switch 2 can communicate among each other. So we have to add or provide additional links. Okay, so that this single point of failure or SPOF, S2F is single point of failure can eliminate. Okay, so this is using the link aggregation. This single point of failure can eliminate using single link aggregation. So objective upon completion of this particular topic, you'll be able to understand, explain the use of link aggregation in the enterprise network, describe the various forms of link aggregation supported, and configure link aggregation solutions. Finally, I will show you the lab. Okay, the lab using the ANS simulator. Please meet yourself when you join the class. Okay, meet yourself. So as I told you, link aggregation is it is a technology that allow us to bundle or to combine or to combine multiple physical links into a single logical link. Okay, so as you can see on the screen, switch SWA and SWB are connected through 3 different physical links. This is link 1, this is link 2, and this is link 3. Okay. Okay, this switch 1 and this is switch 2, or SW and SWA and SWB. Okay, so the switch 1 and switch 2 are connected using 3 redundant links. Okay, the first is this is one first link, second link, and third link. So even though these are 3 different physical links, but logically they are grouped into a single logical link, and this link is called Ethertrunk link. This is not physical link; it is a logical link. Okay, please take note of this. This one is a logical link. Okay, this is not physical link. Rather, this is a logical link. This is a logical link. So link aggregation provides for increased bandwidth. How link aggregation can increase the bandwidth? How link aggregation increase bandwidth? As it says, link aggregation provides for increased bandwidth, enhanced reliability, and support load balancing. What does it mean when you say link aggregation increase bandwidth, enhanced reliability, and support load balancing? Is there anyone who can try? Is there anyone? Is there anyone who can try? How link aggregation can increase the bandwidth? Is there anyone can try?
That means yes. If I have if I have a Siri interface,
Okay.
Giga, they will bundle the Siri must say on the speed of the bandwidth, the speed of gigabyte, I think is yeah, 1000 Mbps. That means I have Siri to combine these three.
Yes, 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 yes. Thank you very much. Yes. Okay, yeah. So let's say if you have 3 links, okay, this SW1, okay, let's call this, sorry, let's say we have this is HW1 and the another switch HW2, okay. So if the HW1 and HW2 are connected through 3 links, okay, 3 links, and each of those 3 links have 1 gigabytes gigabit per second. Each of those 3 links, then if you combine these 3 links into a single logical link, then we have total of 3 gigabits per second, okay, Gbps, okay, capital G, small b, small p, small s. So we have increased from the 1 gigabit per second into 3 gigabit per second with the help of or by implementing link aggregation technology, okay. This is, and another scenario, if let's say this interface have 10G, if individual links have a 10G bandwidth, then we combine the 3 interface into a single logical pipe, then you have what 10 plus 10 plus 10. The total bandwidth of this logical pipe will be what, the sum of all this physical interface. So this is 10 plus 10. This is what, the 10 plus 10 plus 10, it will become 30 gigabit per second. Okay, this is a big advantage. This is a big advantage. So with help of link aggregation technology, we have improved or increased the link bandwidth. The second is enhanced reliability. Reliability means, so reliability means what? For example, let's say if 2 switches are connected, for example, switch 1 and switch 2 are connected using 3 links, then assume those 2 links are active, currently active links. Okay, those 2 links are currently active. Those 2 links, if this any of those 2 links is failed, then the backup links, this is the backup link will take over the role of the primary active link, because the active link is failed, then this backup link becomes active. Okay, then with help of link aggregation we can improve the enhanced reliability also. Okay, when reliability means when the primary link or active link fails, okay, then the backup link will take over, or the backup link will become active link. This means, okay. And the third advantage is support load balancing. Load balancing, okay. Load balancing means, let's say you have multiple inputs, okay, connected to switch 1, and switch 1 and switch are connected using 2. I'm using 3 links. So instead of forwarding or transferring all the packets coming from this employees through switch A to switch B, instead of forwarding all the packets using a single link, and this link may become congested. Okay, at the time, what we have to do, we have to forward some packets using this link and some of the packets using this link. Okay, we have to forward all the packets in all active links equally. This will allow us to load balance the traffic, and by allowing the load balance, implementing load balancing, the network congestion will be reduced. Okay, the network will not be congested. So this is the main advantage of link aggregation. So please take note. Don't forget this 3 main advantage of link aggregation. The first is it increases the bandwidth, okay, network bandwidth, and the second advantage is enhanced reliability, and the third advantage is support load balancing. Please take note. Don't forget the 3 main advantages of link aggregation. Okay, link aggregation. Please take note. The first is it increases the bandwidth of the link. It enhances the reliability of the network, and the support load balancing. Okay, support load balancing. Okay. So
So load balancing means load sharing.
Yeah, load sharing, yeah. Hello, can you hear me? Hello.
Yes, I can hear you.
Okay, thank you. So
You're welcome.
application area of load balancing. Okay, I'm sorry, ether trunk or link aggregation application area where you can implement. This is where we can implement the link aggregation technology. Okay, so as you can see, this is part of enterprise network. This is enterprise network. Is an enterprise network. Okay, this is enterprise network. So in this enterprise network, as you can see, we have the access switch. This access switch, multiple access switches are connected to the network, and we have the distribution switch, and this is the core switch, and this is the ingress router. Okay, so in this case, the distribution switches are connected. That means the switch C and switch D are connected using a redundant link. Okay, as you can see, so this is and this core switches are also connected using the redundant link, because in an enterprise network we can have multiple employees. Okay, multiple employees connected to the network, and when the number of devices connected to the network is increasing and rapidly, then we need, and the number of services increase, then we need a reliable network that can provide services for this network, for those connected devices without interruption. So if you use or if you connect switch C and switch D, that means the distribution switch using a single link cannot provide enough bandwidth for all these connected devices, okay, to support their needs, to support the service they need. So we have to connect this core switch and distribution switch in a redundant link, okay, to support multiple services by providing higher bandwidths, okay. So in this case, between the switch A and switch B, which means the core switch link aggregation is implemented, and also between the distribution switch link aggregation is also implemented. So application is made at critical point to enhance throughput of the data. So when we have multiple services running in our network, okay, or if the number of employees connected to the network is very big, you have to implement this technology to enhance the reliability of the network. Okay, because when multiple employees are connected to the network, this particular link may be congested. Okay, may not be enough to forward the whatever packet is coming from the employees. Okay, which are connected to the access layer. We have to provide an interface which can provide higher bandwidth. Okay, so this is achieved using the link aggregation. So how we can implement link aggregation? There are two modes, link aggregation modes. Okay, the first is the manual load balancing mode, and the second is the static LSP mode. Okay, manual load balancing mode, and the second is the static LSP mode. The first manual load balancing and static LSP mode. Okay, is there anyone who can tell me the main difference between manual load balancing mode and static LSP mode? Is there anyone? Raise your hand and tell me. Manual mode is also called manual load balancing mode. Okay, manual mode is equal to manual load balancing mode, and this LSCP mode is equal to static LSCP mode. Okay, so is there anyone who can tell me the main difference between manual mode and static LSP mode? Is there anyone? Is there anyone can try?
So link aggregation control protocol, I think is a open standard.
Open standard. Okay, good. What's the difference between the
It's
manual
link-
mode and continue, please.
I think the manual mode you configure manual on
Okay.
the post switch.
Okay. What about in static LSP mode? Thank you. You have tried. Thank you. Okay, thank you. So, as I said, in manual mode, as its name implies, it's manual. Okay, it's manual. It's the job of the network administrator. We have to create the logical interface, the ether-trunk interface, and we have to add the interfaces, the physical interfaces, into the logical interface. Okay, manually, one by one. And the other difference in manual mode is all the interfaces are in forwarding state. Don't forget, please, this one. In manual mode, the first is, okay, I cannot hear you. Can you hear me? Can you hear me? Can you hear me?
Yes, I can hear you.
Okay, thank you. So let me tell you the main difference between manual mode and the LSP mode. In manual mode, as its name implies, we have to add the physical interfaces to the logical interface manually, okay, one by one, okay? There is no protocol that help us to add these interfaces, okay, automatically. And when we troubleshoot, we have to check manually as well. So in case of manual mode, all the interfaces are in forwarding state, okay? There is no backup link, or that means there is no backup link in manual mode. All links are what? In forwarding state or active. They become active, okay? But in case of LSP mode, it is LSP mode is also called a static LSP mode. Static LSP mode. In this case, there is a protocol. And the protocol is LSP. LSP is the protocol. It is an abbreviation which stands for Link Aggregation Control Protocol. It's an abbreviation. Okay, let me write it down. LSP stands for, okay, LSP means or stands. LSP stands for Link Aggregation Control Protocol. Okay, Link Aggregation Control Protocol. Sorry. LSP stands for, sorry for that, LSP stands for Link Aggregation Control Protocol. Okay, this is a protocol. Okay, this is a protocol that help us to manage the physical links. Okay, okay. So in manual mode, as I said, all links are in active state or in forwarding state. But in case of LSP static mode, so we can specify the number of active links and the backup links. Okay, for example, in this case, as you can see in the first scenario, all the links are in this case, all links are in active state, okay, or in forwarding state. But in this second case, the links, as you can see, the two switches are connected using 3 links. So the first two interfaces are connected or forwarding state. But the third one is what? This red. This red indicates a backup link. There is one backup and 2 active. 2 active links. This means what? 2 active links, okay? 2 active links and 1 backup link. On this is also known as M ratio n. M is number of active links and n is number of inactive or backup links. Okay, so active links are the links which are what which are about to forward the packet or which are in forwarding state, whereas backup links are what in inactive links, which means they cannot forward packets unless the any of those two backup any of those two primary or active links fail. Okay, if any of those two, any one of those two active links fail, then the backup link will become active or will take over the responsibility of the primary active link. Okay, and in the SP mode we can specify. Okay, we can specify the maximum number of active links. Okay, I think in Huawei it is possible to have at maximum of 8 active links. Okay, the maximum number of active links that's allowed in Huawei device 8. Okay, 8. Beyond that we cannot have maximum of or more than 8 links. Okay, we can configure 8 active links at a time, and the minimum is 2. The minimum is 2. The minimum 2 and the maximum is 8 number of active links in Huawei device. Please take note about this for those who are preparing for the HCIA exam. It will be important. The maximum number of links that we can configure to become active links is 8, and the minimum is 2. Okay, and in active link, all in LSP mode, all links are not in active link. Okay, please take note. In manual mode, all links are in active mode or in forwarding state. Whereas in case of static LSP mode, we have active links and backup links. Okay, so you have to take note about this. You have to take note of this. Okay, so in manual mode, all links. Okay, all links. Let me change the color. In manual mode, all links. Okay, in manual mode, all links load balance and are forwarding. This is as I told you. Okay. As its name implies, manual load balancing mode. It's called as manual load balancing. Whereas in LSP mode supports backup links for redundancy. Yeah, there is a backup link for redundancy. The main purpose of this backup link is to eliminate the problem when the active link becomes failed or broken. Okay, then the backup link will become active immediately, and we can specify the delay time in after how many seconds should be this backup link become active link. Okay, in case of static LSP mode. So in general, in this static LSP mode, first how the active links is selected. How for example, as you can see in this, 3 links are connected between the 2 switches. So switch 1, switch 2 are connected using 3 links. So from these 3 links, only 2 links are active, and the 3rd one is backup. So how these active links are elected? Who can tell me? How is the election of active links performed or in static LSP mode? Based on what criteria? Okay, based on what criteria? Is there anyone who can try? Is there anyone who can try? Hello? 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 Is there anyone who can try? Hello? So okay. So in static LSP mode, the criteria for selecting the active link and backup link is the first criteria is the first criteria is based on the system priority. The first is they have to select the actor. Okay, the actor. So the actor will chosen based on system priority, and the default system priority is 32768, and the second criteria is MAC address. The second criteria is MAC address. The first is based on system priority, and the device which have lower system priority will become as actor. For example, assume this is system priority of 100. This is 100, and this is the default. The default is 32768. Then this will become the actor. Okay, the actor. Then and so. Now, since the switch one is the actor, the switch one will decide the active links and the backup links. So if you configure the maximum number of active links is to become 2, then we have to choose 2 interfaces to act as active interface and 1 backup. So based on what criteria? So the second criteria, if the 2 switch have the same system priority, the second criteria is based on MAC address. Based on MAC address, and the system which have lower MAC address, okay. The system which has lower MAC address will act as this actor, okay, actor. So for example, switch for switch HW1 is MAC address of HW1 is AA and SWT is BB. Then switch A or switch 1 will become actor. So based on this criteria, the actor will be chosen. Then the next is selecting of the active interface. The active interface is also selected based on what? The first system priority, no interface priority, okay? And if those interfaces have the same, for example, by default, all the interfaces have the same priority. So the interface which have lower priority will become active. And if all those interfaces have the same interface priority, the second criteria is MAC address, interface port number, not MAC address, port number. For example, if the first is gig 001 and the second is gig 002 and the third is gig 003, then the first two, gig 001 and gig 002, become active, and the third one will become backup. Okay, then this is actor. Then the non-actor or the passive device will try to negotiate. Okay, try to negotiate the interfaces which are connected to the active link of the actor system to become active. Okay, so the decision is made upon the actor. So this is the criteria. This is the criteria to select or to elect the active interface. The first is based on interface priority, and if all the interfaces have the same priority, then the criteria will be based on MAC system. Yeah, the criteria will become based on interface port number, and the interface which have lower priority will become active, and the interface which have the lower interface number will become active. Okay, so in this case, this means 2 active interface and 1 is backup interface. I think you can read it about this in HCIP. Okay, in HCIP. So this is how the selection takes place. So let's see the data flow control. So the data flow control. So please take note on this. So when you configure ether trunk or link aggregation between 2 devices, okay, we can configure link aggregation between 2 switches, switch 1 to, as you can see, switch 1 and switch 2, or between switch and router, or between router to router. That means layer 2 to layer 2, layer 2 to layer 3, or layer 3 to layer 3 device. Okay, please take note this. Please take note. And when you configure link aggregation, okay, there are certain things you have to take in mind. So please take note. The first is the duplex mode. Okay, so the duplex mode should be the same. Okay, the duplex mode should be the same, and the speed should be the same on both ends. For example, in switch A and switch B, the duplex mode, the speed should be the same, and all interfaces which are going to be grouped to a logical pipe should be also the same. The interface type, the first is, let me write it down, the duplex mode should be the same, duplex mode, and the second is the speed. Okay, the speed, and the third is the interface types, and number of interfaces, interfaces and other criteria. Yeah, should be. Yeah, the VLAN also should be in the same VLAN. VLAN ID should be the same. VLAN ID should be same. And what's left? What's left? The mode also should be the same. Okay. Mode and the other criteria is the mode and the ether trunk ID. Okay. Ether or ETH trunk ID also should be the same. Okay. Let me tell you one by one of this. What does it mean, each of this? So the first is the duplex mode. This is, for example, we have two switches, switch A and switch B are connected using ether trunk or link aggregation. So in order to implement link aggregation between these two switches, this criteria should be made. The first is the duplex mode. For example, if you configure the in switch A full duplex, where in switch B half duplex, then packet loss may happen. Okay, packet loss might happen because the duplex mode should be the same, and the speed also should be the same. For example, in switch A 1000 and in switch B 2000, this is what packet drops. Some packets with a lower, which have within the switch which have lower speed might be dropped. Okay, so the speed also should be the same, and interface type. The interface type should also be the same. For example, if this switch, this two interface are gigabit and is fast Ethernet, we cannot group different interface types into a logical type or into ether trunk. Okay, so the interface type, for example, interface type B, we cannot combine fast Ethernet interfaces with gigabit Ethernet. Okay, gigabit Ethernet interfaces, or gigabit Ethernet interface with Ethernet interfaces. Those two interface types should be the same. This should be the same. For example, gigabit Ethernet to gigabit Ethernet, and fast Ethernet to fast Ethernet, and Ethernet to Ethernet. I know most of the S57 series of Huawei switches are all of those switches are gigabit Ethernet interface, and the number of interfaces. This is also mandatory. Number of interfaces should also be the same. If you create ether trunk on switch A and which have 3 member interfaces, but in switch B 2 member interfaces, this will not work. Okay, number of interfaces should also be the same. If the number of interfaces in switch A are 3, then in switch B also 3. Okay, 4. Okay, 2. The number of interfaces also should be the same. VLAN ID should also be in the same. VLAN also be. I know this is more advanced, but if you want to know, you can read it. Okay, this is more advanced. But the mode, this is the most important. Mode. The mode means, for example, if we have let's say we have connected two switches. We have connected two switches, switch 1 and switch 2. Okay, switch 2. Then using link aggregation, 3 links. Okay, 3 links, and if you implement or configure the link aggregation, then if you configure the mode of switch 1, okay, is manual, whereas in switch 2 is static LSP, then this link aggregation will not work. Okay, it will display error message. Okay, mode is not compatible. Okay, because the mode also will also be the same. Okay, mode should also be the same. So LSP or manual. Okay, so when we use this manual mode, so manual mode is applicable in what kind of scenario? Yeah, manual mode is applicable in case we have two switch, for example, switch 1 and switch 2. And if switch 1 is old switch, or switch 1 does not support this LSP technology, okay, LSP protocol, then we have to implement manual mode, because in order to use this LSP, static LSP mode, both switches should run LSP. Otherwise, we have to use manual mode. Okay, and if those two switches are able to support LSP, static LSP, will implement LSP. So the mode is also important. Okay, mode is also important, and ether trunk ID is also mandatory. The same. Just two switches should also be in the have the same ether trunk ID. For example, in this case, ether trunk ID of 1 and ether trunk ID of 2. This will not work. Okay, this will not work. So ether trunk ID is integer. It is an integer ranging from 0 to 63. Please take note. Okay. The last number of, or the maximum number of ether trunk that can be configured is ID is this 63. So ether trunk ID is integer and range from 0 to 63. So this is, I think there is a question. The what is perfect way to configure ether trunk? I think if the device, all devices are able to support the link aggregation control protocol LSP, it is recommended. It is recommended to implement LSP mode. Okay, it is, because in LSP mode, when the active link fails, then the backup link will become active immediately with less delay, without the interruption of the network administrator. But in case of manual mode, if the active link fails or broken down, then you have to manually add manually add other interface to act as to become active, or to replace the role of the broken active link. So, but in case of LSP mode, it is then is help of protocol. So it's recommended to implement LSP, static LSP mode. Okay, static LSP mode. Thank you for your asking. So this is the step how we can configure static LSP mode. LS or link aggregation in layer 2. This is in layer 2, not layer 3. So the first step is assume we have two switches, and the switches are connected using link aggregation. Switch 1 of gig 001 and gig 002, and switch B of gig 001 and gig 002. So the first go to the global view. This is close brackets. The first go to global view and create. The first step is create the interface. Okay, first create the logical interface. Okay, the first step is create the ether trunk. Okay, trunk interface. This is the first step. Then the second step is mode, configure the mode. Okay, mode, implement the mode or configure the mode type. And the third is add member interface. To it. Okay, to it. So in this case, we have created the interface. Okay, then to create the ether trunk interface, the command is the first type this command interface, then space eth-trunk, then trunk ID. This is the ID that I told you. This ID ranging from this is the ID. Okay, this is the interface ID, the logical interface ID, and this ranges from 0 to 63. Okay, this ranges from 0 to 63. This is the range of the logical interface. The command is first type. Okay, the command is first type interface, then ether trunk, then trunk ID. Then go to the interface. For example, go to the interface, then interface type. This is the interface, the interface type, and interface number. This is the interface number. Okay, this is nothing but this is the interface number, and this is this one is interface type. Okay, this one is this is interface. This is interface type. Okay, interface type means we can have gigabit Ethernet, fast Ethernet, 10G. Okay, interface, and this is the command. This is the command interface. Then what you have to do is once you are in the interface view, then type ether trunk trunk ID. For example, if you have multiple ether trunk in switch A, for example, this is what ether trunk 1 and another ether trunk 2, another ether trunk 3. Then you have to specify to which logical interface, to which ether trunk is this interface belonging to. So in this case, this is what 2 ether trunk 1. So if it is ether trunk 2, ether trunk 2. If it is ether trunk 3, ether trunk 3. Okay, you have to specify. And the same step also is performed in gig 002. So in gig 002 also first you have to go to the interface view, then type ether trunk 1. So I will show you in the lab quickly. Okay, quickly. So link aggregation requires the binding of physical member interface to ether trunk. Yeah, it is mandatory to bind the physical interface, the physical interfaces. So this is in layer 3, in layer 3, in layer 3. So in layer 3, it is the same, but there is a mandatory command. This command is mandatory since ether trunk is by default it is layer 2 interface. Okay, layer 2 interface. So in order to use this ether trunk in layer 3 device, we have to convert from layer 2 to layer 3. Okay, so in order to do that, the command is first go to the ether trunk interface, then first it creates the interface and go to the ether trunk interface view, then run this command undo port switch. Undo port switch. This is mandatory. This switch, for example, this switch and this command will allow us, or if the by default, for example, if the interface by default layer 2, then after running this command, it will convert to layer 3. And if by default the interface is in layer 3, then after running this command, it will change to layer 2. Okay, so this command is mandatory.
So it will convert to routed port.
Yeah, from layer 2 to layer 3. Okay, since we are talking in layer 3. Yeah, so there are two routers, router A and router B. Please take note, okay? Don't forget. Whenever you want to, for example, in what scenario can we use this? For example, in what scenario? For example, if to connect the routers, the ingress router in redundant way, okay? For example, we may have enterprise network and with 2 ISP links, and this is R1 and this is R2, okay? And in order to in order to connect these two routers using link aggregation, okay, then we have to do this command because this ether trunk is by default layer 2, so we have to convert from layer 2 to layer 3 device. Okay, so then the next is the core switch, and after core switch the next is the distribution, and after distribution then access switch will also do that. So the most important thing in this is you have to run this undo port switch command. Don't forget, without running this command, then it will not work. Then after that, you can put an IP address to this logical interface. Okay, you can put an IP address. For example, in this case, IP address is 10.100.1.1/24 submit mask. Okay, this is submit mask, and this is the IP address. Okay. Then here, for the second interface also do it the same thing, and in router 2 also the same thing. Okay, in router 2 the same thing. Now we are in. So the first is in general to implement logical or link aggregation. The first is what you have to create the ether trunk interface. Then after creating the ether trunk interface, you have to what change the mode. Okay, the mode of the aggregation, and whether it is manual or it is static LSP mode. And the third step is you have to add member interface to it. Okay, you have to add member interface to it. So I will show you quickly in the lab. So this is displaying aggregation. Displaying link aggregation information. For example, you can use, there are a number of commands, but in this case, for example, if you type display interface and ether trunk and the trunk ID 1, then it will tell you whether this interface is up or down, and the line protocol current set is up or down, and the number of interface or member interface, how many interfaces. For example, in this case, 2 interfaces, gig 001 and gig 002 in router A both are up and they are with 1. So the total number of ports in trunk is 2, and number of ports is 2. So there are other informations or other commands as well. Okay, to member links ports have been assigned to ether trunk 1. This means, yeah, just two interfaces are what member of this ether trunk according to this information. Okay. So quickly, let me okay. Quickly, let's quickly answer these questions. The first question is: if an administrator attempts to add, an administrator attempts to add gigabit Ethernet and fast Ethernet interface to the same ether trunk interface, what will occur? What will occur is the first question. Please take note. This is very good question. Okay, this is very good question. You can try. If an administrator attempts to, network administrator, suppose you are working as a network administrator in a company and your boss assigned you to implement the link aggregation with different interface, for example, gigabit Ethernet and fast Ethernet interface to the same ether trunk interface, what will occur? Is there any problem that occur? So, or it will work correctly? You can try. You can try.
It will not work.
Network? Why?
Because the ether trunk, it should be in the same board. No,
The same.
yeah, I can use fast.
The same interface
Yes.
type, yeah. Excellent.
Yeah.
Yes, the same interface type. I told you this. I told you this, guys. So in order to configure the ether trunk, the interface type should be the same. I have said you interface type. We cannot add gigabit Ethernet and fast Ethernet interface to the same ether trunk interface. Either both this interface should be either gigabit Ethernet or fast Ethernet. Okay, so this will display error. So this will not work, and rather it will display error. Okay, it will display error. Please take note. This will display error. Okay, because the first interface is gigabit Ethernet and the second is fast Ethernet. Okay, and the second question: in order to establish backup member links, which mode of link aggregation should be used? Which mode?
Here we use link aggregation control protocol.
Excellent. Can we use the manual mode to establish or to have backup links? Can we use the manual mode? Excellent. So the answer is, in this case, we have to implement the static LSP mode, because as I told you, the manual mode, as its name implies, manual load balancing mode. All interfaces are active. All interfaces are forwarding. So there is an active member link in manual mode. But in case of static LSP mode, we can have active links and inactive links, and inactive links are just the backup member links. Okay. So active links are the links which are forwarding the packets, which are in forwarding state, whereas the backup links are the links which are inactive, or in they will not forward. They will not forward the packets. Rather, when the primary or active link fails, then they will become active, or they will take over the responsibility of the active link. Okay, so the answer for the second question is, in order to establish a backup member links, which mode of link aggregation should be used? The answer is a static LSP mode. But in case of manual mode, there is no backup member link, since all links are in active mode. This is, please take note this. So by now I will show you the labs. So before I move to the lab session, do you have any question? From what we have seen so far? Do you have any question?
So engineer, if I have two different vendors, like I have one side Cisco switch and another side Huawei switch, how can I configure Ether trunk or link aggregation between two different vendors?
Okay.
So I mean the preferred way. Can I use the static or I use the link aggregation control protocol?
Yeah, you can use, because these are standard. There are standard protocols. Okay. Static LSP mode is not Cisco proprietary or Huawei proprietary. Okay, you have to use the standard one. If you use the proprietary, it will not work, because Cisco proprietary will only work in Cisco device, and Huawei proprietary only works in Huawei. So you have to use the standard. And I think LSP is also working in both devices in Cisco. For example, this is Cisco and this is Huawei. Okay. You can implement this static LSP mode. It's possible. Clear?
Also, Cisco, I can configure Ether trunk manual on Cisco also. Also, can I use the same in the both side?
Yeah, possible.
Oh, okay. Thank you so much.
Thank you. You're welcome. So by now I will show you the lab. Okay, quickly. Do you have any question? So this time I will show you the lab. So let me share the screen. The ANSP. Okay. So I will show you. Okay, can you see the screen? The packet I'm sorry, the ANSP simulator. Can you see?
Yes, I can see. Yes, I can see.
Okay, can you see the screen writer also? The pen? Can you see?
Yes, I can see.
Okay,
yes.
Thank you for your feedback. Thank you. Okay, so this is the topology. This is the topology that I have prepared for you for this session. So in this topology, what I have done is I have connected two switches, switch 1 and switch 2. Okay, SW1 and SW2, and the two switches are connected using three links. I have connected them using three links. The first is, as you can see, so the three links, and this, what we are going to do is we will create the link aggregation, or we will bundle them to three interfaces to a single logical interface. Okay, so that they can act like a single logical interface. So the interface number for the first switch is gig 001, gig 002, gig 003, and for this second switch, gig 003, gig 001, and gig 002. So can you see this topology? Can you see the topology? Okay, thank you. So this topology, and two in-device are connected. Okay, the first is PC1 and the second is PC2. This is the second is PC2. So PC1 IP address is 10.1.1.1/24, and PC2 IP address is 10.1.1.2/24. Okay, and the interface, the physical interface coming out from the switch 1 connected to PC1 is gig 004, and this interface. Okay, and the interface coming out from switch 2 connected to PC2 is gig 002, the same interface ID. Okay, the same interface ID. So as you can see, /24 means this shows that both PC1 and PC2 are in the same network address, so they can able to communicate. Okay, they can able to communicate to each other. They're able to communicate to each other. This means PC1 can communicate to PC2. Okay, from PC1 can communicate to PC2, and vice versa. Or PC2 also can communicate to PC1. So let's check it first quickly before starting the link aggregation. Okay, let's start quickly whether they are able to communicate or not. Okay, so let's ping in order to check the connectivity. First, go to or double click in PC1, or right click in PC1, or double click in PC1, then go to command this tab. Okay, this tab, and can you see it? The CLI of the PC1. Can you see?
Yes, you see.
Thank you. So I'm trying to check the connectivity between PC1 and PC2. So first, I have to make sure whether PC1 and PC2 are able to communicate or not. Okay, in order to implement the link aggregation. So I'm trying to check the connectivity. So in order to check from connectivity from PC1 to PC2, we have to do what? We have to go to the CLI of PC1, then type ping, okay, ping, then followed by the IP address of the destination IP. So our objective is to ping from PC1 to PC2, then ping 10.1.1.2. Okay, since this is the IP address of PC2. So let's check this quickly. So ping 10.1.1.2. Okay, enter. Yes, 10.1.2. 10.1.1.1. Let's check the configuration. 10.1.1.1 55 and 10.1.1.2 55. Yes, it's correct. So let's do it again. Yes, now it's working. It's working. Yeah, can you see it? The ping message. Can you see it?
Yes, we see the replying from the reply is coming from 10.1.1.2.
Yes, from PC2 to PC1. So this means
Yes.
5 ping packets are sent from PC1. Okay, this is 5 ping packets. The first packet, second, third. No, no. This is the first. Sorry. This is the first packet, the second, the third, the fourth. Yes. So all 5 ping packets and 5 ping requests. The first request and the second is reply. So 5 ping requests has been sent from PC1 to PC2, and 5 ping reply has been received by PC1 from PC2. Okay. So this is TTL, means time to live for each packet, and this is important. This TTL value is very important. So this TTL value will eliminate the loop in layer 3. Okay, in layer 3 loop, this will eliminate the loop in layer 3 communications, and this is the maximum number of average time that takes this packets to transmit and receive, and 5 packets transmitted and 5 packets received. In total 10 packets. Okay, in total 10 packets. So this message shows the communication between PC1 and PC2 is successful. Okay, PC1 and PC2 are able to communicate now. So the next is, let's check one more time from PC2 to PC1. Okay, this is also ping 10.1.1.1. This also works. Okay, this, yeah. So the communication from PC1 to PC2 is successful, and the communication from PC2 to PC1 is also successful. So the second session is to implement the link aggregation technology. So double click. I am starting the implementation or the configuration of the link aggregation. Okay. So the first is, can you see the HCIA of the search?
Yes, you can see.
Thank you. I will zoom out. Okay. So the first is, since I'm right now angle bracket, this angle bracket shows you are in user view. So in this level, user level or user view, we cannot configure the link aggregation. We cannot run the link aggregation commands. So in order to do the link aggregation, you have to switch from user view to global view. To do that, the command is system -view. Okay, this is the command. Write it down, then press enter. Yes, once you type this command, it will change or redirect you from the angle bracket to close bracket, as you can see. And this is the default device name. This is the default device name. Wow. So let's change this device name quickly. Sysname, and the command is sysname sw1. Okay, sw1, and let's do the same thing in switch 2 also. Okay, in switch 2. Sorry, then this name is sw2. Okay, let's clear the screen and let's clear the screen. Then the second step is, as I told you, in order to implement the link aggregation, the first step is to create the intertrunk interface. Okay, so the command is type interface, then followed by what kind of interface. As if you type question mark, you have a number of options. The first is, are you going to create intertrunk, gigabit Ethernet, or loopback? Okay, and interface, tunnel, or VLAN if. So for this session, we are going to create What type of interface? Ether trunk, then ETH, then tab. Press tab, the ether trunk, and for the next step is to specify the trunk ID, okay? As I told you that the trunk, ether trunk interface, a number, it is an integer which ranges from 0 to 63, okay? So let's give it 1, okay? Ether trunk ID of 1, okay? By now I have created the ether trunk, okay? The ether trunk interface already created, okay? And now we are inside the ether trunk interface view. So let's quit from this quit, then let's check display interface, ether trunk, display interface, ether trunk, then question mark, then the number of the ID, okay? The ether trunk ID. This is the, let's clear and run the command again. So this is if you run the display interface ether trunk, then the ID of the ether trunk interface, then it will tell you the state the ether trunk currently. Hello.
The screen, it was big. Now it is good. Yes, just make this size.
Not good.
Yes.
So this side. Okay. Not good.
Now it's good. Now it's good.
Okay. Thank you.
The size is good now.
Okay. Thank you. So as you can see here, since we have not added any member interface to the ether trunk interface, state is down. Its state is down. This means that this interface is no more forwarding any packet. Okay, no more forwarding, and it doesn't have any member interfaces added to it right now. So in this case, as you can see, the sorry for that. Yeah, it works now. So in this case, as you can see, the ether trunk current state is down, line protocol current state is down. Okay, it says down. It is not administratively down. Okay, and the total number of ports, I'm not seeing any port numbers or member ports added to this, and this is the physical MAC address, and the maximum frame length is this one. Okay, so once we add member interface to this, then the interface will display here, and here's the member interface, and their name will display, and their status and their weight also displayed here. Okay, then this also, the number of ports in trunk is 0. It says 0. Then after adding the interface, the member interface to this logical interface, then it will count them. It will count them, and it will tell us the total number of app interfaces. Okay, total number of app interfaces. That's but before and the second important thing, in order to implement the link aggregation technology correctly, you have to specify the mode. Okay, to specify the mode first, what you have to do, go to the interface, then ether trunk interface, the interface ID, then mode type mode. Okay, mode. Then you have two types of options. The first is static LSP mode, or the second manual. So right now I'm going to show you how to implement the static LSP mode. So what you have to do, you have to select the LSP mode. Okay, so LSP, then press enter. Then what's left? Display this. The mode is static LSP mode. Okay, mode. Then you have to specify the preemption delay. Okay, so for example, what does it mean? Preemption delay means, so let's say you have two switches are connected. Okay, switch 1 and switch 2 are connected using link aggregation, and 3 interfaces are bundled together to implement this link aggregation. So and from this 3 interfaces, so this is the first 2 are acting as active interface, and this is backup. So in case this primary interface or active interface fail or down, then after how many time delay will this backup interface will become active interface concept? Okay, this is the delay. You have to specify the delay time. Okay, the delay after how many seconds? Okay, or how many minutes? Actually, we cannot use the minutes. Okay, it is too long. Okay, so you have to specify this number of seconds. After how many seconds this backup link will act or take over the responsibility of this failed link is the concept. So to do that, you have to enable first preemption delay. So LSP preemption enable, first enable, type this command, preemption enable, then specify the delay, preemption, LSP preemption delay. Okay, delay is the default is 30 seconds. Please take note, the delay, the default, okay, the default delay, preemption delay time is 30 seconds. This is the 30 seconds. So we are not using the default. So right now I will make it 10, okay, 10. So the delay is 10 seconds, okay. So this means after 10 seconds, if any of the active links are down, then the backup link will become the backup link will become active link, okay, will become active. So I will show you, okay. So display this spaces, you have to specify the mode, the delay time, okay. The second is, and the next step is you have to add interface, okay, member interface. To do that, first interface gigabit 0/0/1, then what you have to do is trunk 1, okay. Yes, to add this interface to the trunk interface, the first is what, this are physical interface, okay. This is physical interface. So to add this physical interface to the ether trunk or logical interface, the first command is you have to go to the interface view and interface type, interface number, then type this ether trunk 1, ether trunk, then ether trunk ID, which ether trunk you are going to add this one. For example, if you want to add to ether trunk 2, then this type ether trunk 2, ether trunk 3, ether trunk 3, like that, okay. So then what is left for the second interface also? This is display this. You can put some description, for example, description about this interface. For example, this interface is member of ether trunk 1, okay, something like that. Display this. So let's screen display this. Yes, you have configure the description, you have to configure the ether trunk ID, okay. Let's do the second interface quickly. Interface gig 00/2, then copy and paste ether trunk 1, okay, ether trunk 1, and description, okay. This interface is connected to ETH trunk 1, the trunk 1. Finished, okay, finish it. Right now we'll check it. This display ether trunk, okay. The pop-up message is disturbing me, by the way. So display ether trunk 1, run this command, display ether trunk 1, okay. It will tell you number of information. For example, the preemption delay time, okay. Please take note. Are you hearing me, everyone? Can you hear me?
Yes, I hear you.
Okay, thank you. So
Yes,
please take note of this thing. Please take note, okay. So when you type this command, display ether trunk, then ether trunk ID, you can get this information. The first is the preemption delay time. The first, by default it is 10, not 10, it was 30, but we have configured it to be 10. So this is the 10 second. The system priority is 32768. This is the default. We haven't changed this one, okay. And the system ID, this is the ID, maximum active links. As I told you in the presentation, the maximum active links allowed in Huawei device is 8. So please take note of this thing. Please take note. The maximum active link number is 8, and number of apport in trunk is 0. Apport and the member interface. Okay, this is the actor name and the partner. The partner is switch to. Okay, this is since the system priority is 32768. So we haven't changed this one. So we'll change it right now. And these are the active or the member interfaces. These are the member interfaces. 2 interfaces are added manually, and we will add one interface, third interface. Then, and it says unselect here. Status unselect, their port priority is same, the port priority is same, port number is different. Okay, so in this case I will show you which ports are active, which port will become backup. Okay, so let's add one port quickly. So the first interface, ethertrunk 1, then let me clear the screen, then no create interface gig 0/0/3, then ethertrunk 1. Okay, then clear out, clear, then display ethertrunk 1. Yes, as you can see, we have added a third interface. Yeah, can you see this one? Can you see it?
I cannot see.
You cannot see? Okay.
Yeah.
Right, what about right now? Can you see this one?
Yes, now I can see. Yes.
Okay, thank you. So we have added 3 physical interfaces, okay, to the logical interface. So still now all of the 3 interfaces are their status unselect, because we have to configure the link aggregation on the second switch as well. Okay, so that the actor and the partner will negotiate. Okay, so the status of all the 3 interfaces unselect. Their port type is 1G ports, and their port priority is the same. Okay, their port number is different, 234. Okay, 234. Their weight is the same. So the once we configure on the second switch, on the switch 2, then we will see the result. Okay, I will run this command again to see the difference. So what's left, then LSP, you have to change the system priority. As you can see, this is the default. The default system priority is 32768. I need to make this switch actor. So in order to make this switch actor, we have to change the system priority something lower than this value. So LSP, the priority, the command is LSP priority, and this is the priority value. Okay, you can put 0 up to this number, but the default is 32768. So right now I need to make 100. Okay, 100. Okay, so let's quickly run display ethertrunk 1. Yes. Right now the system priority is changed. Okay, the system priority changes, so it is 100. Then let's quickly configure the on switch 2. Okay, on switch 2, then the first step is system view. Then we haven't created any ethertrunk interface. Yeah, display ethertrunk. Yeah, we haven't created. Yeah, so the first is interface, the trunk ID 1. Then the mode should be the same, LSP static, and LSP preemption enable, and LSP preemption delay 10 seconds. Finished. Yeah, the second step is before adding yeah, the second step is to add the member interface gig 0/0/1. Okay, then the first is ethertrunk 1, and can put description, okay, as you want. For member of ethertrunk, okay. Then and for the second interface gig 0/0/2 ethertrunk 1, sorry, ethertrunk 1, and for the third interface gig 00/3 ethertrunk 1. Finish it. Yeah, so what's left? This. So let's check let's compare the information that we get from switch 1 and switch 2. Let's run this command, display ethertrunk 1 on both switches. Okay, this is okay. Can you see it? The screen. Can you see the screen? Hello? Can you see the screen? Can you see the screen?
Can you reduce the size?
Okay, okay.
Can you reduce the size? Yes.
What about
Yes.
now? Is visible?
Yes, now it's okay. It's okay.
Okay,
Yes.
follow me. Okay, follow me, please. Okay. Previously, when we run this command, display ether trunk, then trunk ID, what information we got was this is the preemption delay time 10, the system priority is 32768, and the maximum active link number is 8. Okay, maximum active link number is 8. It says 8. Since we haven't specified the number of maximum links, so it makes all these interfaces or it selects all interfaces to become active because the maximum is still 8. So we have to reduce the maximum active link number into 2 in both switches. So to do that, LSCP max, I think LSCP, the command is not, sorry, the interface. Let me make the maximum active link number will be 2. Third trunk 1 max. Okay, maximum, yeah, maximum max active. Yes, this is a command. Maximum active link number question mark, then it says max 8. The value of maximum active link number is 8. So right now I need to make 2 links active. Then this is display this. The command is this one. Okay, go to the ether trunk interface, then run this command. Maximum active link number is 2 on both switches. Then also interface ether trunk 1, then maximum active link number is 2. So let's quickly run the command. Display ether trunk. Display ether trunk 1. Ether trunk 1. So as you can see, previously it was 3. Number of port in trunk was 3, but right now it is 2. Okay, since we specified the maximum active link number to be 2. So even though 3 links are connected, but 2 links, only 2 links will be act as active links, and the third one will become an active backup or inactive link. Okay, as you can see here, gig 001 and gig 002 are active, which means selected means they are what, acting as active links. Well, but gig 003 is inactive. On unselect means it is backup link, ማለት. It's backup link, okay? It's backup link, not active link. So this is, and the port priority is the same. Even though port priority is the same, how it should decide gig 001 and gig 002 are to become active links, because what? The port priority is, the first criteria is the port priority. But right now the port priority is the same. So the selection is performed based on the port number. The port number, since the port number for gig 001 is 2 and port number for gig 002 is 3, then the two interface will become active, and the third, the interface which have higher port number, higher port number will be act as backup. Okay, so 2 interfaces are active, and the third one is inactive or backup. And which one is the actor?
So yes, I have a question. Sorry for an interrupt. So the election first, it will be on the priority.
What do you say?
The election.
Yeah.
The election. I mean the first.
Yeah.
On the priority.
The election is performed based on port number. This one, okay? This. Okay.
This is the second election port number.
Yeah. The first is the port priority, and if the interface have the same port priority, then the second election criteria will be the port number. Okay.
Okay. Thank you.
Thank you. Okay, you're welcome. So this is the information. So let me run the same command on the actor switch. Okay. So display ether trunk, display ether trunk 1, trunk 1. As you can see, here, the delay is 10, then system priority is 100, and list active number is list maximum is 2, and number of active link number 2. Okay, operating status is up. So 2 interfaces are also selected here. Okay, gig 001 and gig 002, and this is the partner information. Switch to. Okay, switch to is system priority is 32768. This is switch 2, and this is switch 1 information. Switch 1 is acting as actor. Switch 1 is acting as actor. Okay, switch 1 is acting as actor. Let me run another command. Display interface trunk. Sorry, trunk. Display interface trunk dash trunk 1. Display trunk 1, and from this command you can get information about which interface is down. The status of the interface, particularly down, it says number of ports up 3, number of total ports 3, and up ports are 2. They are white. And other command is display interface, then trunk interface. It's the same thing. Display interface, not interface. Display trunk. Yes, this also displays you the system ID for each port. Okay. So let me ping. Okay. So let me ping from PC1 to PC2. From PC1 to PC2. Ping 10.1.1.2.2 10.1.1.2. Yes, 10.1.1.2. It's networking. Okay, let's check. Let's troubleshoot it quickly. Okay, display trunk 1 and hello. Hello.
So engineer, so the interface Giga 0 by 3 is down.
The interface, yeah. Gig 003 is down. Gig 001 and gig 002 are in active mode. Active. Okay. Let me put some interface VLAN if one IP address is 10.1.1.324, and for this switch interface VLAN if one IP address 10.1 and .1.4. Okay, that's 4 / 24 times mask. Then let's ping -3 ping packets to 10.1.1.3. Yeah, 3. It's working. Yeah. Can you see it? It's visible, guys. Can you see the screen?
Yes,
So,
yes.
Okay, follow me right now. Follow me. Since we have made the delay of the backup link to become active link. If in case the active link fails, it's 10 seconds. Then what we will do is we'll shut down. We will shut down the current active link. Okay. Then what we will see the effect. What will happen after how many seconds or how many packets we will lose during the
I think 10
entire.
seconds. 10 seconds.
Okay. Okay. What I will do is I will shut down the one active link from switch 1. Okay. Switch 1. Then I will ping from switch 2 to switch 1. Then we will see the effect. Okay. So let's right now ping minus 3 packets to 10.1.2 is working fine. It's working fine. This is from switch 1 to PC2. From switch 1 to switch 2 is this one. Okay. It's also working fine. From switch 1 to PC1 is also working fine. So what I will do is I will shut down the one active link number. So interface gig 00/1. Then I will ping from switch 2 switch 1. Okay. So that's ping minus 100 ping packets to switch 1 is 10.1.3. This is 3. It's right now it is working. So let's shut down this interface. Shut down. Okay. I've shut down the primary link. The primary, as you can see, only one ping request is time out or lost. Okay, or only one ping packet is lost, as you can see. So let's again undo the shutdown interface to become active interface. Okay, let's undo. Control C. Let's ping again from PC1. Display current configuration. The default, yeah, this is 10.1.13 is IP address of switch 1. So, and what I will do is ping minus C 110.1.1.1. Okay, this is from switch 2 to PC1. Right now it is pingable. So I will revert back the shutdown interface to become active interface. So interface gig 0/0/1, then undo shutdown, then it will become again active interface. Then if you see no packet is lost, no ping packet is lost. Okay. But after since the current active interface is down, then after 10 seconds the interface will become active. Okay. Can you see the output?
Yeah.
So understand, please. This is happening due to the current interface is shut down. So yes. After 10 second delay, it becomes active. Okay, it becomes active again. So this you cannot see this. Yeah, you cannot see this. Do you have any question?
So I have to wait 10 minutes, 10 seconds.
Yes, after 10 seconds, you have to wait 10 seconds, but you cannot able to see in production environment. Since we are talking about in a simulation, okay? You will not be able to see in a production environment in a PC or laptop, okay? So after 10 seconds, the connection become since the original interface become active, then it will take over the responsibility to become active interface, and the third interface. Yeah, will become backup.
Yes. So if in production network, 10 seconds is too much. 10 seconds is too much.
You can reduce it. You can reduce it to 5 seconds. 5 seconds or as you want. Okay.
Okay, thank you.
This is the lab. Okay, this is the lab. So I think it is enough. It is enough for HCIA level. So at HCIA level, it is enough, and I think this is enough for today's session, for today's webinar. And before ending the today's webinar, can you have something to say to me? Do you have anything that you want to say for me, or you want to ask, or any comments or suggestion?
So I want to see. Thank you so much for the class.
You're welcome. You're welcome. Thank
So
you.
your
Okay, go ahead.
yeah. So mashallah, your explain everything is clear. Thank you so much.
Thank you. Thank you. You're welcome. Thank you. Thank you. Okay, and I will see you on other webinars. So I hope you will enjoy it. So thank you
So
for
inshallah,
joining me.
thank you so much. Inshallah. So we are waiting you. Inshallah, in another class.
Thank you. Thank you. Thank you. We will continue other webinars. So I will notify you through the WhatsApp group. Okay.
Inshallah. Just engineer. Can you send the record in the group WhatsApp?
Okay. Yeah.
So
I
to
will,
review
okay.
and to do the
Okay.
practice.
Okay, I will upload it.
Inshallah.
Okay, I will upload. Thank you. Thank you for joining me. So thank you very much. Thank you.
You're welcome. You're welcome.
Okay.
Assalamu alaikum.
Bye. Bye. Bye.
Bye.
Okay. Bye.